Alright, here's our first look at an M8 motor. Customer brought in for me to look at it, I guess. So, missing a few parts. So this one's been worked on before. Damn bus out there making noise. So here's the counterbalancers in these things. So they're going to leave this thing out, he said. It has a sprocket, comes off this side. Looks just like a twin cam crank other. So it's on the left side of the bike is where the drive is at. Goes like that. Ah, great. It plays with the rods as they're going up and down. Great. So Harley obviously had a problem with the bearings coming out because they put a set screw over here to keep it in. And the main bearing, they did the same thing they did on the old motor, on the twin cam motor. They made it really, really thin so they break real easy. If you don't use the official tools, so you got everything has to be well supported if you do any kind of pressing on these things, or you will break the cases, guaranteed. So this one here, they didn't put no screw in here, so I guess they figured they didn't need no screw to retain the bearing. The twin cam in the later years they put the bearings in there, or the screws I mean, somewhere in around 8 or 10 they started putting them in there. I think they're about 10 they put screws in there, 2 of them. So I guess you could put a screw in here. You have to make a little washer right here, crescent shape, to bring up the height to that. And you got a place here and a place here. You can put 2 screws to hold that bearing in. Because what happens when these cranks get out of true, it starts walking the bearings out and it'll push them right out. And then this would drop down and all hell would break loose inside the motor. That's what they used to do on a twin cam. I don't see why M8s are any different. This is all just like in a twin cam, how the bearings are. It's probably the same bearings. They look the same. All of this stuff looks just like a twin cam on this side. The only difference is on this side they got a sprocket over here. Looks like the same rods, no bushing, so the pins eat up the rods and get to buy new rods. So, well, the rods are throw-away anyway, so it doesn't really matter. Harley does not make this stuff to be rebuilt. Everything is a one-time use and you throw it away. So there's no clearance in there to speak of. Yep. It's almost nothing in there. Very, very tight. And then the rod's way, way too tight. I don't know if they're put together tight or just run hard and the rods are oval. When they get oval, they get tight too. The blue is stock because it's all induction hardened, which means they heat it up cherry red and then quench it to heat treat it. There's no races in the rod. They're just crap material throughout. Flywheels are everything just low-ass quality material. They save money on everything they can. So, oh well, typical. So this one they put a feeling cam in here, whatever grind that is, and it failed the cam bearing, which he was going to put right back together. So I would not recommend doing that. So I put my finger, I'm trying to move the bearing, the rollers are going real slow. A lot of drag on the rollers, I don't want to slide. That tells me there's something wrong with that bearing. And then when I see the camshaft, I go, oh yeah, there's definitely something wrong with that bearing. This should be a nice, they should spin nice and pretty like this. When you can't, you put your fingernail in there, you catch it on the edge of your nail and slide it, and it should just slide easy. So, anyways, that bearing's shot. It looks like it might be a twin cam bearing, so I go up and see if it is. If not, we're screwed. Or he's screwed. I'm not supposed to be working on this crap. It's his motor. So they got piston squirters over here. Yep, a couple screws fall out. So the little squirt goes up. So there's the front and the back. That obviously is the back one. Little Torx head screws. Goes like that. There you go, front and back. Why is that not sitting flat on there? That's kind of weird. Just not flat. Something's not flat. The top thread is not chamfered. It was never deburred from Harley, so the edge is sticking up now on both of these. You can see how the edge sticks up a little bit. You can see how it gets into here, so that means when you torque it down, the gasket might not be sealing very well. These looks like format material. They got the steel shim in the middle. The gaskets are the same front and back. I did see that. So they're relying on the gasket to be the deburring thing, so I don't like that. I like stuff being flat before I put a gasket on it. That way you don't really need to have a gasket if you don't have to. So me, I would deburr those holes and make sure this is flat by putting on a piece of sandpaper on a drill press table. See, this table's not flat. That's semi-flat, but not really flat. These tables are not flat. This table's flat here, but it's a little small. You can come off you can put a piece of paper up on top of here. That would be flat. The milling machine kind of would work, but it's got low spots in it. So you can use a table like this. Should be relatively flat because it's a big piece of cast steel. But you also got tables like this that are flat. That drill press table's flat. You put a piece of paper on there and you go back and forth on it, and you flatten out your surfaces and make sure they're flat. Then you make sure you clean all the grit out. You don't want that grit inside that ball right there. Otherwise it'll plug up the hole and it won't work. Plus it'll put the grit inside your motor, which you definitely don't want. So this has those tappet cuffs on there, which helps retain your lifters. Something about the lifters are different. Oh, we didn't need that, did we? Okay, so Harley eliminated the retaining pin. On twin cams, I got a pin that goes across. You just drop down there and it keeps them from rotating. So they eliminated that. Harley got cheap again. One more part they didn't need to put in there. So they probably got some kind of a piece of crap plastic or something that goes there. So this here is a piece of metal that will stay in there good. So my guess is they probably had a piece of plastic that went in here, which doesn't hold up for probably when you put real cams in there. So they make these to go in there. This is obviously the front one. So let's go over here. Once again, Harley does not deburr a hole. There's no gasket here, so that means this will be loose when it's tight. So even till your screw's tight, this is floating around. So you got to deburr it so it pulls down hard all the way down. Otherwise things are loose. Doesn't matter if the bolt's tight, it's still loose. They got a hydraulic tensioner here. Got a real small piston. Oh, they got a pivot on that thing. Oh, great. That's something that's going to fail. Look at that. Oh, it's all plastic too. You know that's quality. So they put a little small diameter plunger in there so the big ones like they used to use. Yeah, wonderful. Quality. And the other thing I saw, there's no O-ring here on the drain back hole. So the cylinders. So these cylinders have a drain back hole. It comes down through here. Goes through that hole right there. Goes into this hole here and then drains back into the oil galley probably right here. So there's no O-ring, so they're only using whatever sealant they got. Harley likes using some kind of this gray plastic, or not, silicone type material. It's kind of, it doesn't feel like a full silicone, but it's not a 3-bond either. I use 3-bond sealer, which is right here. That's the one I use. Yeah, damn light. So that's what I use. So it doesn't ever really dry to be hard, and it's not silicone, so if it gets into your motor it'll grind itself up and disappear, whereas silicone, it stays in there and plugs up everything. So on the cam plate they had a lot of wear issues in here. When the cam failed, it wore away the case. I don't know if you can see it in here, the plate, but there's a big lip in there where it ate it up. Also, you can see a big chunk went through the oil pump, which makes the oil pump not work. You can see I was rubbing real hard here and it's put a big gouge in that. Because when this bearing failed over here, the shaft failed, the whole cam started flopping like that and eating up all this other stuff, because now this is trying to retain the cam instead of the bearing doing its job over there. And, oh, there's the problem. I was on the wrong side. That's the pinion side. That's the cam side. See that big lip in there? That wasn't in there before. See how it's not on that side? It's on this side, and that's how much it wore. This is the pinion snout here. They always get a lot of wear on the pinion snouts because they're bad oil filtration. Even though there's a filter on everything, doesn't matter. Plus, when the crank's out of true, it really loads this bearing surface up and chews it up no matter what, even if you had good oil in there. So you get a little bit of clearance on there. I like that, but that's probably half what it was, or it's probably double what it came with stock. It should be that right now loose. It should be at least that loose when it's new, as far as I'm concerned. All of these surfaces should be. So this is what a fueling plate. There you go. Junk. What the hell's this thing? Well, that's a piece of crap plastic. I'm guessing that's some kind of a breather. I have no idea what that thing does. Where the hell's that go? Beats the hell out of me. Piece of plastic crap. So when you don't take nothing apart, you don't know how things go. It looks like it's part of the oil pump feed system, but that's not it. I don't think this goes in here. I don't know what the hell this thing does. Don't know. Somewhere. Something important. Don't know what it does. Cover just a cover like always, so it doesn't go in that. Yeah, I don't know. So he's going to leave this out. I don't have a problem with that. Oh, it's a split gear to keep the backlash out. There you go. See how they're offset? It's spring loaded so it doesn't get any clearance in it. That's how you make gears not make gear noise. When they're loose, they don't make gear noise. Alright, that's about all we got on this. He was worried about that washer being loose. That's normal. It goes in the crank snout right here. So it doesn't matter. That's a stop. That washer hits up against this shoulder right here. We'll tighten everything down. So it retains your crankshaft. This side over here looks just like a twin cam. So it looks like I got a sensor right here. Oh, that's for the alternator. And I saw they had a sensor on the bottom down here, which is kind of a weird place to have a sensor. That's where you rip off wires of your ground, but with a counterbalancer being in here, they didn't have room for a sensor to go in the front of the case here anymore. There's no room in here anymore. There's a crank, something spinning around in there making vibration things. So, alright, well there you go on that part. Now down in here, here's our wasted oil pump. You see I'll get a big piece of crap in there, destroyed it. Ooh, yeah, that definitely, that'll give you a loss of oil pressure when your galleries are all connected. They don't work very well. Your high pressure side and low pressure side are the same. Doesn't work. That's a primary chain shoe thing. You can see all the metal was in the pistons already, destroying those. So if you're going to reuse these pistons, you got to put a real fine file in here and make sure you got, on the top of every one of these grooves here, there's a piece of metal. You got to make sure you get that stuff cleaned out of there so it doesn't go back in there and tear the motor up. I'm sure he wasn't going to do that. So there's your compensators that cause nothing but problems. I like putting solid sprockets in there so you eliminate all this crap, but it is a little bit harder on the crank and powertrain when you do that, but it won't break. It's all real rough where it's been a lot of metal through it. Some kind of a scoop thing. There's injector manifold, injectors. Here's your alternator. What kind of plug they got now? They got a big 3-wire plug now. Wonderful. Look at that boot they got. That's a big ass boot. Big ass alternator. 1 amperage there. Ooh, they're oily cooling it now. They're getting smart. They're letting oil flow in there to cool things. Oh, geez. I wonder who told them that one. Rest assured, it wasn't Harley that figured that out. Someone else did it. Bunch of crap. Look how much weight you get rid of all this crap. Put a nice solid sprocket in there. Big ass breather or something. Compression releases. Alright, well there you go. So I guess this is the cam drive sprocket. Comes off the crank somehow. There's got to be another gear somewhere. This is on the cam because it's got splines. There must be another one that's somewhere. Comes off of the crank snout. Oop, wrong side. That'd be the same as the twin cam, come off of here. So that goes right in there like that somehow. Gonna be one big fat one in there. Yep, there it is, big fat one. There you go. Pretty idiot proof. I'm assuming these are marks here for something. I don't see no marks in the teeth, so they must be doing something with these marks here. Oh, there's a mark right there. Okay, so these are tooling marks. So these ones here and here, these are drive for the machinery that holds them. These are jigging, so that way they know where to put all the other stuff in there. This is probably a pressed metal because it doesn't look like it's machined. So this is powdered metal, cheap, made to size. So this is going to be all for indexing purposes. So the actual timing mark is right here. So that means this goes in this direction so you can see it, not this way. So this would be a mark. Would go right there, and there'd be the other one would be right below it to be a mark on that one, and you line the two dots up and you'd be good. Simple. Idiot proof, almost. We have lots of idiots around here. We can definitely make it idiot not proof. Yeah, we're good at that. Alright, so when they put this thing together, obviously there was a misalignment to this bearing. Sometimes when you put the bearings in, the rollers will fall over, so they go like that, and when you squeeze them, it locks the roller up. I have that problem every now and then, and if you put the motor together like that, it will cause this damage like that. Eventually the rollers will will align themselves, and once they do, then it'll turn, they'll roll again. So maybe that's what they did on this one, because I don't know how that would fail other than that, because that roller will take a ton of abuse and not have a problem. And I don't know what it is. And that is a full complement bearing in there, whereas Harley, I'm sure, has those caged ones in there because they're too damn cheap to put good ones in there. So my guess is that was assembled wrong. I'm guessing the bearing did not rotate when they put it in there, and it finally rotated after it killed the cam. And all that metal and shit went throughout the motor and did all the oil pump damage, and the cylinder damage would be damaged too because those pistons have marks on them. So I know on the skirts, right here. So I know that all these are here going to be scratches in the cylinders also, so the rings don't work too good anymore. All because they put the cam bearing in there wrong, I bet. I'm 99% sure that's what happened to this motor. So, there you go. I didn't put together, I'm just going by what parts I see. And it did all this damage. Everything here is destroyed. Except for that. But we don't care, we're not using it. And these bearings don't care either because they're splash lubricated, and by the time the oil gets to that, it's pretty clean, so it doesn't hurt them. Plus these are big ass rollers, it's hard to hurt them anyway. But you can see how there's no marks here, there's no grit here. Oh, that rotates now. That's not supposed to rotate. That's bad. I don't like that. Yeah, that should be a press fit. That's stupid. Because that's hardened and this is soft, so you know what's going to happen. This is going to wear, and this will get loose. And your bearing will be loose here, because then the whole bearing will be loose, the crank will be loose. Yeah, so what you do with that is you put Loctite in there. And I just got a bunch of brand new Loctites because I was playing around with Loctites. And there's a bunch of new grades of Loctite out there. So I bought a bunch of them. So this one's 638. So these are green. We got 2 blues, a red, and 3 greens. Now each one of these greens is a different application. So this is a wicking green, which is like my old wicking green, which is over here. 290 was my old wicking green. But this is low holding power. It's only probably something low 2,000 tensile strength, maybe 2,500. Probably about the twos, probably in the low twos. This one is like green should be hard. This one I think is 3,900 tensile, so that's almost double holding power what that one is. But this will wick in. The other thing that is real nice is that word right there. See how it says oil tolerant? That means you don't have to clean these cases very well and that Loctite will work. Or in this case, you take this Loctite right here, you take some cleaner and squirt this thing clean with your brake clean, blow it off a couple times, and then you take that wicking grade and you stick that stuff in there on this side and this side, let it soak in. It'll lock that sucker solid and it won't turn again. And this is also at least 360-degree temperature, because all these are higher temperatures. But there are some stuff that's 425, but I don't think this one is. It might be, I have to look it up. So this one here is going to get used on that application right there. These other ones have different stuff. This one's high strength. Both of these are high strength. I have to go look to see what they are, what I bought these for. I don't remember. But one that goes up to 4,200 tensile. One's high temperature. Went to 450. So one of these is 450. All three of these are 3,800 to 4,200 tensile, as I recall. So that's the holding power. These ones two here. Oh, I got two of the same one. How'd that happen? I fucked up. Oh, I screwed up. Excuse me. So the biggest thing about this stuff, I don't know if I'm buying real stuff or fake stuff. So the new bottles have the Loctite. The bottle looks like this. And you're supposed to be able to identify that this is a genuine product. So there's supposed to be like a barcode thing in here, or that scanner code they got on these, so you can put your cell phone on there. And if it reads it, it's real. If it doesn't read it, it's bad. Someone really wants me over there. Are you calling me? I'm busy. So, but the test is on this Loctite is you take it on a piece of metal, you put a drop of it on there, then you rotate it up. If it runs down the side of it, it's fake. If it stays put, it's real. Now the only one that might change on is the wicking compound, because that should move. But the regular Loctite should just stay there. And that was one of the tests they said on the Loctite website. The other test is you actually test it and see what it does. So this red here is 360-degree temperature, but it's oil tolerant. So that means I can use it for stuff I don't care about, bolts. So you can put stuff together that has oil on it, you have to worry about it. So, you got to clean it out a little bit, but not too bad. This is oil tolerant. This one here is oil tolerant. So these are all oil tolerant. So you got two different labels for the same thing. This is an older style, this is a newer style, but like I said, it might be fake, I don't know. These ones here are not oil tolerant. So one of these is really high holding power. It was like 4,000 tensile. It's my sleeve retainer, which used to be, is that the one I'm missing? Yeah, thread locker. This is my sleeve retainer here. Nope, this is penetrating. Oh, these are both 290. See, I haven't found my chemicals yet. They're still missing. Anyways, my old green light used to say sleeve retainer on it, so it's different. Now, if you look at these labels, see these are said thread locker, and this is retaining compound. So this is made to hold bolts together. This is made to hold parts together. So that's the difference. See how it holds bearings in and stuff like that. These are made to hold nuts. So it's the difference between the different ones. So this industrial stuff over here. This is more of your other grades. It used to be automotive and industrial, but now it's kind of mixed together. But so these are all different grades of Loctite. So I'm going to play around with these things and see what's going to happen. And then all those brand new bottles right there, I'll be swapping over to these. So I'll be experimenting those, see how they work. So anyway, more stuff to play with. So anyway, that's it for this. So there you go, first walk around and what we got going on here, and we'll see how this goes together. Like I said, I don't know what this thing is. He just wants me to sweat the cases up and bolt them together for him. He doesn't trust himself sliding two bearings in and put sealer on a case. I don't think that's very hard to do, but that's me. So anyway, that's what I use it for, because I don't have time to work on it. I'm still trying to get my shop set up. So got more crap over here now from the last video. A lot more welding rod up, put away now. We got weld this case tonight. That's tonight's project. Alright, that's it for now. 6:30. Time to get some work done. Alright, that's it.